All right, so I think this is recording. Let's take a look here at problem number 3. We've got a polynomial function of degree 4. We want to find the zeros, and there are going to be at most 4 zeros. So let's start out by looking to see if there's a greatest common factor. It looks like an x. So now if we look at this reduced polynomial, we need to generate a list of possible rational zeros. The factors of 6 are going to be the possible numerators. And the leading coefficient, which is just 1, that's our denominator. So this list is pretty easy. And remember, it's just a list of possible, no guarantee that any of these are actually zeros. And they're only rational numbers, not irrational numbers. So we take each one of these numbers and divide it by 1. So now we simply go in search of a 0. So I'm going to use synthetic division. We could take the numbers and plug them in and do the arithmetic, but usually the arithmetic is easier with the synthetic division, especially as the numbers get larger when you have large exponents. So if we try 1, we've got 1, -2, -5, and 6. This was in descending order, the exponents, and no common factor, so it is in standard form. And right off the bat, we get lucky and we find a 0. So it's going to help us factor this even more. We already factored out a common factor of x. And now this 1 in factored form is written as x minus 1, and our 3 terms here are quadratic. Your x method can factor this, or since this leading coefficient's 1, just by trial and error, you can immediately see how it factors. So this will give us our possible zeros if we set each individual factor equal to 0 and solve. So we've got 0, and then 1 minus 1 would be 0. 3 minus 3 would give us a 0. And -2 plus 2. So the original polynomial function was of degree 4, and we found 4 zeros. So there can't be any more. All right. Excuse me.